In today's video, we will be looking at conservation of mass. Let's look at an example of what the mass will be of this copper sulfide. If we were to react 5.1 grams of copper with 2 grams of sulfur, how much copper sulfide will we end up with? Pause the video for a moment and write down what you think is the answer. The answer is 7.2 grams. Did you get this right? If so, why? So what is conservation of mass? We will be looking at the definition of conservation of mass, and we will investigate conservation of mass. We will also explain conservation of mass using balanced equations. So how would we do this? First of all, we're going to look at a method that we can use to design and see how we can test for conservation of mass. So first of all, we've got all the different images that can be or will be used. So first of all, what we need to do is weigh a beaker, weigh 20 grams of sugar in a weighing board, pour 30 ml of water into the beaker and weigh it, place sugar into the beaker and stir them both together. We will then weigh both together. And the reason we do this is because we have weighed them before pouring them in together and we have weighed them after. This will show us whether the mass is the same or whether it is different. Once we have figured this out, we will know what we mean by the definition of mass. So just to give you an idea, here is a simple equation. You have magnesium plus oxygen, both reacted together give magnesium oxide. So first of all, which ones are the reactants? The reactants are what you react together. In this case, magnesium and oxygen are the reactants. The product is what you end up with. So once the magnesium has reacted with the oxygen, you end up with the product being magnesium oxide. The product is always at the end of the arrow. It is what you end up with. So what do we mean by the term of conservation of mass? Mass is the amount of matter, what it is made up of. It is measured in grams or kilograms, for example, from the method we looked at earlier, the sugar. What we do know is mass is never lost or gained in chemical reactions. Therefore, we say that mass is conserved. The mass of the reactants, so they're whatever you start off with, is always the same as the mass of the products. Let's look at this example here. So you have 32 grams of sulfur plus 56 grams of iron. Both of them tally up to 88 grams of product. And the reason is because 56 plus 32 is what you start off with, which is 88. Once they have reacted together, they form 88 grams. So why does this happen? Why is mass not gained or lost? The reason is, during a chemical reaction, no particles are created or destroyed. They are simply rearranged, and we will look at an example of this. Here is the example that we will look at, and to do this we will balance equations. We use balance equations to show that mass is conserved during a reaction, meaning it is always the same as what we start off with as what we end up with. When carbon burns, it combines with oxygen to form carbon dioxide. The diagram here shows carbon atoms reacting with oxygen molecules. You may want to do this at home. If you have access to Play-Doh, work out how many carbon dioxide molecules will be made and draw it in your book, and then write out the equation for the reaction. Just to give you an idea, you have in the blue the carbon atoms, and there are 4 of them, and you have 4 lots of oxygen molecules. How many do you think we will end up with? What we should have found was that because there was 4 carbon atoms and 4 oxygen molecules reacting together, we will end up with 4 carbon dioxide molecules, each 1 carbon reacting with each oxygen molecule. Therefore, 4 molecules is what we should have had. Okay, let's look at a few more examples. So here we have the reactants A and B. The product is C. So just to give you an idea, A weighs 14 grams and B weighs 17 grams. How much is the product going to weigh? All we simply need to do here is add the reactants together. So 14 plus 17 is 31 grams. The next example is, again, we are reacting A with B and we end up with the product C. However, in this case, what we have got is we have the starting weight of the reactant, which is 15 grams, but we need to work out what B is. What we do know is the final product weighs 38 grams. So what we would simply do for this is take away 15 from the 38. Pause the video for a moment. What is your answer? Okay, so all you should have done is 38 minus 15, and the answer is 23 grams. Lastly, let's look at another example. So here we have two reactants, which is A plus B, and we also have two products. The same theory applies. The reactants and the products will always weigh the same. No mass is lost or gained. So what we have is A, which is 10 grams, and B, which is 23 grams. So before the arrow, we have reactants weighing a total of 33 grams, which means that the total after the arrow must also equal 33 grams. We know that D is 13 grams, so all we need to simply do here is 33 minus 13. The answer for C should be 20 grams. It is a simple subtraction.